Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Number 20 of NEET 2014 physics paper. Students, let us solve the next question, which is number 20. If N1, N2 and N3 are the fundamental frequencies of three segments into which a string is divided, so that is a string. Suppose that this is A and B, AB is a string, and it is divided into three segments in whatever ratio it is. Suppose that these are the three segments. This length is suppose L1, this is L2, this is L3. Suppose that the total length is L. So you can write that L is L1 plus L2 plus L3. This is the information given. It talks about the fundamental frequencies of the corresponding segments. Suppose this point is C, this point is D. So AC is one segment, CD is another segment, and DB is another segment. It's not clear what is their length, but that is also not required. They might be equal, they might be different. In general, you can take L1, L2, L3 irrespective of their lengths. Now, this length vibrates with fundamental frequency, and obviously the fundamental frequency will be when it vibrates in one loop. So, this way, when it vibrates, similarly, this will vibrate in this way, this will vibrate in this way. So, the vibrate with their fundamental frequency, its frequency is N1, its frequency is N2, and this segment has frequency N3. Then the original fundamental frequency N of the string is given by, that means if I talk about the single length L, then this will vibrate with this fundamental frequency. This way it will vibrate. This way it will vibrate. This is the total length L and its fundamental frequency is N. The original fundamental frequency N of the string. When we don't talk about any segments, only as a whole of the string of length L, then it vibrates with two fixed point nodes. Then its fundamental frequency is N. When in segments, the fundamental frequencies are shown here, N1, N2, N3 respectively. What can you talk about these N? Your question is to relate this N with N1, N2 and N3. That is the question. How this N is related to how they are related. So the relation can be obtained from here. The length is known, that the sum of all the lengths must be equal to the total length. But you cannot say that the sum of all the frequencies is equal to the original frequency. That is not possible. Now what we'll do? We'll use this relation and reach at the relations of N, N1, N2, N3. That means there must be some formula to relate L with N. If you can relate L and want N, so you must have a relationship between L and N. To have the relationship among L and N, we know that for any vibrating string fixed at both ends, this is the fundamental frequency, and the fundamental frequency can be written as 1 over 2L T over mu under root, where N is the fundamental frequency, L is the length of this segment or length of this string, T is the tension in the string, and the tensor that is developed here, and the mu value is called the linear density of the string, that is called mass per unit length of the string. Suppose that string has mass m and length is L, so it is m over L. So this is the thing, this is the formula that we use. Now if so in a given string the tension will remain the same, so tension here at each and every point is same, whether you talk about the segments or you talk about the whole length of the string, the tension will remain same, this factor is same. Mu is also same, because if whether this length is smaller or this is greater or this is much greater, the mu is the linear density of the string, that is also constant. 2 itself is a constant, 1 is a constant, so n and L are related because we want the relationship between n and L. N is related to L as this, that n varies inversely with the length, rest remaining constant, so n is inversely proportional to length. If n is inversely proportional to length, then I can say that n is some constant divided by length, that you can write. So I can also write that that implies L is k divided by n. Okay, so this expression can be written for this length or this length or this length or the whole length, because this is a general relation that we obtain. This is the general relation that we obtained taking L as length, and this is the situation. So I want to apply this formula to these 4 lengths given. So for this L I can write k over n, no problem with that. So the first L I'll write, because the expression is L is L1, L2 and L3. I just got that L is k over n. This formula I'll use. For this I'll write k over n. For this I'll write k over n1, because this length is inversely proportional to frequency. Every length is inversely proportional to frequency. This is the length, this is the frequency, this is the length, this is the frequency. When L is there, n is obtained. When L1 is there, n1 is obtained. Similarly, this will be k over n2 plus k over n3. This constant is same for all these segments or the whole length. So from here, if I cancel this k, then I get 1 over n is 1 over n1, 1 over n2 plus 1 over n3. So what I've done is just cancelling this k, and I got this final expression. So this is how they are related. If I see the option, then the first option is the correct one. 1 over n is 1 over n1 plus 1 over n2 plus 1 over n3. Okay, thank you.